Why hello, you people from Earth and outer space. It is I, Alexander from the universe. In this episode of Let's Java, we'll go over some of Java's primitives, the numeric types. You may remember from a previous episode when we started using variables. And the variables we were using were of type int, which is an integer. Now an integer is a 32-bit signed integer. Now what does that mean? That means that an integer, say I, which is equal to 32 or something, whatever, part of the Fibonacci sequence, 987. This works just fine. We could run this and nothing would happen because we're not actually using it in any way whatsoever. The int is, as mentioned before, it is 32-bit in size. This means that the number needs to be able to be stored within 32 bits of memory. If you go for a really large number, like a whole lot of nines, and then run your program, well, you're gonna see there's a huge error here. Its type is out of range. That's really sad, is it not? But then there's another type of integer which is called a long. Now this is a 64-bit integer, so that we could have slightly larger numbers. Rather than using 32 bits, we're using 64 bits now, which means that there can be a whole lot larger. You see here, wow, that actually went out of... Where is it? Is it there? No? Wait, that worked, right? Yeah. Let's make that an integer. Oh, that works, man. This means that we're at a beautiful place where these nines are just at the right size to be fit in both the regular integer and a 64-bit one. Now this doesn't mean that they're of the same size, because longs are, as a matter of fact, a 64-bit long integer. But there are also smaller integers. Say we want to make an 8-bit integer. These we can do using bytes. Byte I equals 6, for example. If we were to, say, print this out like we would any type, this would work just fine. Look at that, it says 6. But if we were to say a lot of nines, we're gonna get a huge error because this can only be stored inside a larger data type than a byte. Then we also have the short, which rather than 8 bits of memory, we can store 16 bits of memory in here. Isn't that awesome? Like, seriously. Look at that. That's a huge number, man. If we're to make this a byte, this ain't gonna work. Oh no. And these are all the different integers there are in Java. But there are also times where you might not want to have a full number per se. What if we wanted to have a number including decimal points as well? Like, what if we wanted a number, say we had an integer here, but we wanted this number to be 923, probably 987, since that's part of a Fibonacci sequence. We wanted it to be 987.34, for example. Now, this ain't gonna work, because first of all, we got a huge error message there. If we launch it, it's gonna be like, bam, cannot convert from double to int. Oh no, isn't that sad? You see, it says from double to int. Now a double is a 64-bit double precision IEEE 754 floating point number. Now what does this mean? This means that we can store decimal numbers in a really nice fashion. If we were to run this, it's going to say 987.34. So this is 64 bits in size. But perhaps we didn't need that much memory when working with floating point numbers. Now the IEEE 754 you can read up on. A link will be in the description below. But that's out of scope for this tutorial, because then it's getting really, it's getting slightly more advanced. But then, since this is 64 bits in size, we could go ahead and make a float instead. And when using floats in Java, you need to put a F sign at the end of it to tell Java that this is in fact a float. We'll run this, it's gonna say BAM! And a float is a 32-bit single precision IEEE 754 floating point number. You don't need to remember all of this. I'm just babbling on about things you probably don't even care about. But it's good to have a slight overview of all the different data types there are in Java. And the types we went over in this episode is actually all the types we're going to go over in this episode. So there are more types in Java, but it's going to require a whole lot more episodes before everything's going to fall in place in everybody's minds, including my own. I'm getting kind of not saying in here. Yeah. But usually in Java, we stick to using ints and doubles. And when making games, we usually use floats because our hardware usually enjoys that. Good old graphics components, they usually like floats. But keep in mind, integers, 32-bit integers, and doubles, 64-bit double precision, IEEE 754 floating point numbers. The IEEE 754 is in fact the industry standard. So when working with programming languages, you're going to run into this a whole lot. Why goodbye, you people from Earth and outer space. Feel free to leave a comment stating something either hilarious or perhaps even a like. Until next time.